space age, spearheaded by visionaries like Elon Musk, has arrived. One that may see humanity extending its reach beyond Earth to establish thriving settlements on Mars and other distant worlds. Rocket ships now stand ready to thunder into the skies, venturing forth on epic missions of exploration and colonization that capture the imagination. Whilst incredibly exciting, these journeys into the unknown also come fraught with hazards that will test the mettle of those brave pioneers willing to risk all for the future. Before we dive deeper into this complex subject, be sure to subscribe and hit the notification bell to join our engaged community. So, coming back, what exactly drives humans to attempt such ambitious colonization across the gulfs of interplanetary space? With Earth's population swelling past 8 billion, overcrowding strains resources and accelerates climate change. Seeking room to expand, some look skyward for solutions. The drive to explore and discover new frontiers also beckons strongly. For centuries, people have wondered whether life exists on other worlds, and now at last they can go see for themselves. Of course, the lure of adventure calls to many explorers and thrill seekers as well. The opportunity to be pioneers on an alien planet simply tantalizes the imagination. But where exactly should humanity set its sights on off-world colonies? Destination selection depends on many critical factors. Most promising are planets or moons with environments not completely inhospitable to human life. Searching for water sources to sustain colonists narrows options significantly. Ideally, new worlds should contain accessible ice, subsurface aquifers, or at least raw materials that can be processed into water, oxygen, and hydrogen fuel. Scouting missions analyze planets for the presence of key resources like metals for construction, minerals for manufacturing, and soil for agriculture. Energy sources must be available, whether solar, geothermal, or nuclear. Locations receiving decent sunlight provide an advantage. Proximity to Earth is also important, as trips of 6 months or more expose colonists to debilitating health risks from radiation and low gravity. Of the candidates, Mars checks the most boxes, relatively close at 7 to 9 months travel time, and appears to have substantial water frozen at its polar ice caps. To ferry colonists across such immense distances, spaceship design and engineering must make monumental leaps. They require powerful rockets just to escape Earth's gravity, durable heat shields for safe atmospheric entry and landing, and advanced life support systems providing artificial gravity, breathable air, food and water throughout months-long journeys. Radiation shielding must protect passengers from intense cosmic rays and solar flares. Giant centrifuges spinning on gimbals might generate artificial gravity for health. Greenhouse modules packed with grow lights could supplement food. Closed-loop water recycling and air scrubbers would be mandatory. To stave off boredom and isolation, deep space habitats also offer crew lounges, gaming and exercise areas, and even simulated landscapes like parks and forests. Of course, all systems feature multiple redundancies, as mechanical failure could spell disaster. These first intrepid colonists will ride modern-day covered wagons into the unknown, facing dangers in pursuit of new frontiers. But the payoff could be no less than securing the future survival and advancement of the human race. Upon landing, colonists will need to quickly establish shelters on alien worlds to support human life. Domed cities made of transparent plastics and composites allow natural light while containing breathable atmospheres. Underground habitats dug into lava tubes and caverns provide shielding from radiation and meteor strikes. Colonies might start in sectional modules similar to space stations, later connecting and expanding into larger complexes. Structures must stand up to unpredictable conditions like Mars's global dust storms and extreme temperature swings. Buildings could be 3D printed from Martian soils using autonomous robotics. Creative architecture patterns towns inside crater walls for protection, while opening dome ceilings to the sky for views. But simply having a pressurized enclosure is not enough. How will these colonies procure necessities for survival, including air, water, food, and energy? Mars's thin carbon dioxide atmosphere is unbreathable, so oxygen must be produced from resources on hand. Water, too, will be synthesized through mining ice, collecting permafrost melt, or extracting and purifying it from hydrated minerals. Grow labs filled with genetically modified crops under artificial sun lamps offer renewable food sources. Vitamin-rich algae cultures also supplement diets. Nuclear fission reactors provide reliable energy for heating and electricity. Abundant solar panels will also harness Mars's daily dose of sunlight. Methane fuel and oxygen, scrubbed from the air, provide stovetop propellants. With in-situ resource utilization, colonies can live off the land instead of overly relying on supplies from Earth. But even meeting physical needs, prolonged stays take a toll on mental health. Far from Earth and loved ones, in a bleak landscape, isolated colonists face elevated risks of depression, stress, and declining cognitive abilities. Staving off space madness requires proactive efforts. Positive social interaction in community groups and gaming activities boosts morale. Counselors address psychological issues. Adequate living spaces prevent feelings of confinement. Simulated outdoor landscapes and augmented reality visors provide soothing natural scenery. Routines give structure, while creative arts and education programs spark fulfillment. As colonies grow, new generations born on Mars gain a sense of belonging to their new world, allowing a colony to develop its own unique identity and culture. In fact, Mars colonies will likely transform from small scientific outposts into complex societies with political, economic, and cultural dimensions. With communications to Earth subject to minutes or hours of delay, local governance and decision-making become necessities. Governing councils balance worker, technician, and leadership representation. Economies expand beyond survival to issues of compensation, property, resources, and trade. Social organizations arise around shared interests like religion, recreation, or education. A spectrum of careers expands. Areologist scientists study the planet, while teachers and engineers pass knowledge to children. Unique Martian cultural identities form over generations, shaped by the landscape and experiences shared in their new home. Advanced robotics and artificial intelligence will also prove essential for establishing colonies, though not without certain risks. Self-driving rovers can scout ahead of human explorers, studying terrain and environments. Excavation drones construct habitats underground and mine minerals. With superhuman precision and strength, humanoid robots assemble structures. AIs monitor life support systems and manage nuclear reactors, freeing colonists from mundane work. Machine learning algorithms even design technologies optimized for their new environments. But reliance on automation has downsides. Equipment breakdowns endanger lives when maintenance personnel are few. Hacking or software glitches may corrupt AIs managing critical infrastructure. Human control and oversight must remain active, and colonists should avoid surrendering creative work solely to AI systems. To flourish, human culture must still have outlets for art, creativity, and innovation. In the end, the colonization of space represents a transformation in the destiny of humankind. The dangers are real, whether equipment failures, supply shortages, natural disasters, or health threats. Lives will be lost. But the planets call to us for a reason. Our survival as a species may one day hinge on becoming an interplanetary civilization. And the human spirit demands we rise to the challenge. If successful, new spheres of human scientific achievement, culture, and discovery will blossom. Just as the first pioneers crossed oceans to discover new continents, humanity now traverses the cosmic ocean. The farther we voyage into the unknown, the more wonders we might find awaiting us.